Now, just before we start, if you look on the Moodle page, Ben, are you sending them? You have it? If you look at the Moodle page, I made a link for you to oh sorry, that should say coursework 1, not coursework 2.
Pardon?
You can upload your maths coursework. Go, I was just saying to Ben, I made a link on Moodle for you to upload coursework 1.
Okay.
When you're finished,
Yeah,
don't worry, you have until the 3rd of May.
3rd
Of May. Alright, that's like...
compare.
No, that's too far away.
No, it's
No.
No,
No.
we need to finish part 2 in the coursework 2 before 3. Before 3.
No, coursework, the maths coursework 1. What we did today.
okay. One is coursework 1 has part 1 and part
Task 1, task 2.
Yeah.
I thought we need to finish the coursework 2.
No, we haven't started coursework 2.
Good.
So, we'll say the end of the month. The end of the month.
2. I don't care.
Good. I got my task 1 back. Yeah, where?
Okay, that's fine. Now let's continue with the maths lesson. Okay, so what we're having a look at now,
One line.
integration of simple rational functions. Go! Are you ready? It's taking forever, come on.
Oh my god.
Relax.
It's yesterday.
We continue from yesterday.
The same idea.
Yeah.
Yeah. I
So
think
is
so.
Except we
It's-
need this rule from yesterday. Integrate 1 over x squared plus 1 dx equals tan inverse x plus c. We did this yesterday. Oops.
What?
Didn't we?
10.
Yeah.
how you converse to 10.
No, the implicit lesson.
Get it?
Oh, no. Go back 2 lessons to the implicit lesson, right? If you look at question 12D,
12D.
12D,
Okay.
you learned that if y equals sine inverse x, then dy dx equals 1 over root 1 minus x squared. We did this, remember?
Yeah.
And you also learned in the next question, what was that?
The
12f.
okay.
12f. If y equals tan inverse x, then dy dx equals 1 over 1 plus x squared.
Oh.
We did that in the class. 12D and 12F. Yes, Ben? What? What's wrong?
What page?
Implicit. What page does that go? Tell him.
100. So I forgot what's the dy dx for tan?
For
It's
tan?
Sine over cosine? Cosine over
1
sine?
over cos squared is the derivative of tan. No, what's wrong? Guys, what's wrong? What's wrong? Ben, what's wrong? What's wrong? Do you not remember doing 12D and 12F?
I remember the D, but I didn't do the.
Okay, well, it's the same idea. Right? So
we drop the.
Look, okay, if the derivative of sine inverse is this, it means the antiderivative will equal sine inverse x. And likewise here, the antiderivative of that will equal tan inverse x. Okay, you need these are needed for today's lesson.
What a second.
What?
I just. Yeah. Here. Why? It's just 2x. Oh.
No, that's a different question.
What?
This one is not 2x, this is dx. If you prefer, I can write 1 here and put dx here.
I know.
Oh, okay, so what's the question?
I just question why after 2x it becomes 10. Or maybe I should do this. Okay.
Okay.
So dy equal sine inverse x plus c.
What?
dy.
dy? No, look. If you want to integrate one...
Integrate.
Integrate.
Oh, okay. Got it.
Okay.
Can I actually... Okay.
It's
So,
more
what I'm trying to teach you today is how to integrate simple rational functions. What is a rational function? Let me tell you. If you have a linear over a quadratic, or maybe you have a constant over a linear, or maybe you have a linear over a quadratic, etc. These are all simple rational. Rational here means a linear and a quadratic, or a quadratic and a cubic, something like this. Okay, these are called rational functions. Yeah? Now, we'll have 4 important examples, but before we start, you need to know these 2 new rules. Okay, so do you want to write these 2 down? Rule 1, Rule 2 for today's lesson. You got that? Okay, guys might be so tired. Right, can I scroll down? Scroll down. Okay, example 1. Easy example to start with. I ask you to integrate minus 8x plus 6 over minus 4x squared plus 6x plus 5 dx. For these ones, what you do is easy. You just make u equal to...
minus 4x
Yep,
squared.
that's a good job, Ben.
6.
Plus 5. So that means du dx equals...
minus 8x add 6.
So that means dx equals du over minus 8x plus 6. So this equals minus 8x plus 6 over u du over minus 8x plus 6. Cancel. 1 over u du. What does that equal, Ben?
It's ln u. ln minus 1.
Yeah.
Wow.
I said it the first time.
Plus c.
Don't forget C. Yeah. Okay. Next.
C.
That makes me didn't get A star.
Okay. Next.
Okay.
You have this pen?
No.
Yes. Okay. Next one. Integrate 6x minus 7 over 2x minus 9 dx. So, go. What do you think we make u equal to here?
2x minus 9.
Yes. So what is du dx?
2.
So what is dx?
Du over 2.
Good. So this is equal to 6x minus 7 over u
And
du
over 2.
over 2. Ah, but there's a problem.
Can't cancel.
Can't cancel. So,
We change
X equal.
u.
yeah.
So x equal u minus 9 over 2.
No, it's not. U plus 9 over
Okay.
2.
Yeah.
There we go. Okay. Yes? Yes. So that's equal to 6 u plus 9 over 2 minus 7 over
U.
u du over 2. So, look here, that goes into that 3 times. So this becomes 3u plus 27 minus 7 over u du over 2. So that's equal to 3u plus 20 over u du over 2. So that's equal to 3 over 2 plus 10 over u du. Because we can split this into 2 and divide by 2. So that's equal to 3 over 2u plus 10 log u plus c. So that's equal to 3 over 2 2x minus 9 plus 10 log 2x minus 9 plus c, which is the same as 3x plus 10 log 2x minus 9 plus c.
Oh yes.
Oh, so no constant here.
There it is.
Yeah,
Makes
but we
sense.
cancel the first bracket.
Yeah. Okay. Harder, yeah?
It's okay.
It's okay.
It's you a little quick.
Ah, it's good for you.
Yeah, I think so.
It's good for you.
Okay.
Okay. Next example is shorter. You want to integrate 16 over 4x squared plus 1 dx. Now, you know what I'll write as 4? I'll write it as 4x squared plus 1, yeah. Now, what do we make u equal to, do you think?
4x squared plus 1.
Yeah, not here actually. Not here. So here's... No, not
4
16.
square.
No. What you do is you make u equal to square root 4x squared over 1, which is 2x. So if you have here these two, you use u as the root of them. So use u as 2x. Okay, so watch. What does du dx equal? 2. So what does dx equal? du over 2. Okay. Also, if u equals 2x, what does u squared equal?
4x squared.
And so what does u squared plus 1 equal? 4x squared plus 1.
2x.
So this becomes 16 over u squared plus 1 du over 2, which is equal to 8 1 over u squared plus 1 du. Now, if you use the rule at the start of the lesson, what does this equal?
10.
Yeah, tan inverse u. So the answer is 8 tan inverse 2x plus c. So this is the trick.
So if it's 4x squared plus 2, we use
4x squared over 2. Yeah. Got that?
8 10 minus 2x.
Yeah. Scroll down. So the last example, integrate 16 over 4x squared minus 8x plus 8 dx. Now, what do we let u equal to here? Well, actually, the first thing we should do is divide by 4.
It makes like x minus 1.
Yeah, what's that called, Gil? Ah, you do know.
What? I've
Complete.
completed it.
Complete the what?
Square?
Yes. So this is equal to 4 over x minus 1 squared plus 1. So that means u equals root x minus 1 squared over 1. So u equals x minus 1. So this means du equals dx. Also, it means that u squared plus 1 equals x minus 1 squared plus 1. So then this is equal to integrate 4 over u squared plus 1 du. So take the 4 out, and this becomes 4 tan inverse u. So that's equal to 4 tan inverse x minus 1 plus c. Good? Yeah. Yeah. So you have about 10 minutes left. I'll give you, how many questions will I give you? Will I give you 4 or will I give you 8?
Kind, please. Kind.
Okay, I'll give you 4 to do now. So I did A, so you could try, let me see, you could do 1. No, I'm picking a good, I'll pick a good one. Pick a good one. 1B, 2B, 3E, and No, no, let me think. Let me think. For
F.
E.
Okay.
For you to do.